Okay, in this section, we start talking about conic sections. And by definition, a conic section is a cross section of cones. That's all it is. That's the reason we call it conic section, cross section. So a conic section is formed by the intersection or the cross section of a plane and a double napped right cone. So you see the double cone right here? A double napped cone is a two cone opposites of each other extending infinitely. So this thing doesn't stop here. It keeps going up. So extending infinitely upwards and downwards. The angle of the plane creates the types of conic sections. So let's label each conic section below. If you have a plane that is parallel with the base of this cone here, this would be a circle. So that cross section in that cone is a circle. If we tilt it just a bit, all of a sudden we have an ellipse or an elongated circle. Slant it some more and notice the slant here. If you were to extend this on forever, that would be a parabola. And then finally, if you have you've got one that's perpendicular with the base here, this is called a hyperbola. If the cross section is perpendicular there with the base. Okay, let's start out talking about circles. And we've done circles for several years now. The standard form of a circle or equation of a circle is x minus h squared plus y minus k squared, let's try that again, is equal to r squared, to where hk is the center. So that's our transformations. If you just had x squared plus y squared with no h's and k's, the minuses and pluses there shifts your circle left or right or up and down. So that's what the h and k is. It shifts your center. Is the center of the circle, and r, plain old r, not r squared, but r would be the radius. So this over here is not the radius. This is the radius squared. So if this is a 49, that means the radius would be 7. So let's talk about what we mean by a locus of points. All conics have a locus. A locus is simply a group or a set of points. It's all these points, all these grouping of points that satisfies a certain condition. And I went ahead and I gave you the definition of a circle based on a locus. For a circle, the locus, by definition, a circle is the locus of all the points that are equidistant from a given point. So like if I told you, take this point right here and draw every point that is 3 units from that. 3 units up, 3 units right, 3 units down, 3 units left, 3 units northeast, 3 units southwest, 3 units southeast, 3 units southwest, and keep going. Every point that is 3 units from there, well, if you connected all of these points around through here, what do you get? You get that circle. And that's by definition what a circle is. It's every point, the locus of all points that are a set distance, some distance from a given point, which is the center of that circle. So now let's go ahead, let's graph some of these. It says identify the center and the radius. And again, remember our basic form to where center, the h and k shifts it backwards from what you would think. And then you have the r squared over here, the radius squared. So therefore, the center of this first one, because the minus 1 has been shifted right 1, so your center, I'm going to put a C in front of it. The center has been shifted right 1 and then up 2. So your center of this circle is located at 1, 2, right here. The radius of this circle, this is r squared. So what number squared gives you 64? That means the radius would be 8. So what I'm going to do is this is the center of my circle. I'm going to take and I'm going to go up 8. I'm going to go right 8. I'm going to go left 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, which is located right there. And I'm going to go down 8, 1, 2, 3, 4, 5, 6, 7, 8. If you were to connect, this is only 4 of the many points on this circle, but if you were to connect these dots, you would have your circle. And there it is. I nearly missed it right there. Number 2, and you can draw these any way you'd want to. If you've got a compass, obviously is the best way to draw these, or you can just try to freehand them. First off, let's find our center. Notice there's no value on the x, so the center is located at 0 if there's no plus or minus there. The plus 5 is going to shift it down 5. So 0, negative 5 is going to be your center. 1, 2, 3, 4, 5, which is located there. The radius squared is here, so that means the radius is the square root of that, which is 3. So center is at 0, negative 5. The radius is 3, so let's go 3 in every direction. Connect our dots, and there's your circle. Next one, it says rewrite the equations in standard form. So these are not in the form that we'd like to have them in because, again, we have x squareds and y squareds, not 3x squared. So how do we get that by itself? Notice it says note that we may need to complete the square, and we'll go over that in just a second to get it in that standard form. But on number 3, we don't. On number 3, all we have to do is divide every term, including this one, by 3. And that gives you x squared plus y squared is equal to 64. And now let's identify our center and our radius. The center, notice that there's no plus or minuses on x or y, so the center is located at 0, 0. R squared is 64, so that means the radius is 8. Number 4. Now this one's just mixed up is the only problem. You have x minus 4 squared in the right place. However, this minus y squared is going to have to be moved over to turn it into plus y squared. This minus 52 needs to be moved over here with the rest of the radius, so that would give you equals 54, and then you're in the right place because you had 4 terms there. So just shift those terms around till you get them where they need to be. The center of this circle has been shifted right 4 and up 0. The radius squared is 54, so that means that the radius is the square root of 54. However, square root of 54 is not a perfect, nice, neat square root, so let's just simplify that. The square root of 54 is the square root of 9 times the square root of 6, so we'll just call it 3 root 6, or you could write that as a decimal. Definitely when you're trying to graph it, we would want to write that as a decimal just to see what is that equal to. Okay, here we go. Now we have to complete the square. If you have x squared stuff mixed with x stuff, y squared stuff mixed with y stuff, this is one of the completing the squares problem. What you're going to do first is group your x's together. X squared plus 6x, leave a space. Group your y's together. Y squared plus 2y, leave a space. The constant term, move to the other side where the radius goes. Now we're going to complete the square. If you don't remember completing the square, the way you do it, you're going to take half of this term, or the coefficient of this term, which gives you 3, and you're going to square that, multiply it times itself. The rule is, though, if you complete the square by adding something to it, you must do the exact same thing to the other side. You are also going to complete this square. Half of 2 is 1. 1 times itself is 1. Make sure you add it to both sides. We now have 2 completed squares. After you complete the square, the next step will always be to factor. You're going to ask yourself what adds to give you 6, multiplies to give you 9. If you worked it correctly, it'll be the same values. It'll be 3 and 3. So this is now a completed square because when we factor it, we get x plus 3 times itself. Same thing here. What adds to give you 2, multiplies to give you 1 is 1 and itself. So this is going to factor into y plus 1 times y plus 1, a completed square. On the other side, you have negative 6, 9, and 1, which gives you 4. Now it looks like the form that we're used to seeing. The center of this circle has been shifted left 3, and it's been shifted down 1. There's your center. The radius squared is 4, so that means the radius would have to be 2. Let's try it again. Group your x's, so you have x squared minus 14x, leave a space. Group your y's, plus y squared plus 4y, leave a space, equals, move the constant to the other side. To complete the square, you're going to take half of this and multiply it by itself. Don't forget, because I do a lot, don't forget to add it to both sides. Do the same thing here. Half of this, multiply it times itself, add 4 to both sides. When you go to factor this, it should be a completed square. It should also always factor into whatever half of this is. So you have your x times x, and then what adds to give you this should always be half of it, negative 7, negative 7, and that does give you the 49, plus. Should be a perfect square. Y times itself gives you y squared. What adds multiplies to give you a 4 and a 4. Should always be half of this term, so plus 2, and that does work. Equals 32 and 49 is 81. So therefore, the center of this circle has been shifted right 7 down 2. So the center is 7, negative 2, or you can just take the opposites of those. The radius squared is 81, so the radius must be 9. Okay, the next one, number 7, doing the exact same thing. We've got our x's grouped already, x squared plus 20x. Leave a space. Let's move our y squared over, so plus y squared equals. My 103 is a constant. Let's move over there with a 4. That's going to give you a negative 99. Now, there's no other y stuff, so this is done. The y part is you can't complete that square. Now, the x's I can complete, so take half of 20 is 10, multiply it by itself. Let's add 100 to both sides. Let's now factor one set of parentheses because it's going to be a perfect square. X times itself gives you x squared. Adds, multiplies should be half of 20. And then, like I said, just leave the plus y squared equals 1. So your center has been shifted left 10 and up 0. And your radius squared is 1, so that means your radius is also 1. Next one, group your x's, x squared minus 8x. Leave a space to complete the square. You have plus y squared. Let's move our 12y's over by doing minus 12y. Equals, move all constants to the right, and that is just negative 7. So now everything's grouped. Complete the square, half it, square it, gives you a positive 16. Add it to both sides. Half it, square it, gives you positive 36. Add it to both sides. X stuff, try again. A perfect square. X times itself is x squared. Half of this is negative 4. Perfect square. Y times itself is y squared. Adds, multiplies should be half of this, which is negative 6. Equals 9 and 36 is 45. So therefore, the center of our circle has been shifted right 4, up 6. The radius squared is 45, so the radius is root 45, or the square root of 9 times the square root of 5, and there is your answer. Number 9, doing the same thing. X squared has no other x stuff, so it's finished. Let's move your y squared over. You've got your plus 8y. Leave a space to complete that squared. Move your 13 over. It gives you 92. The completed square, we don't have to worry about the x squared, but let's take half of our 8, multiply it by itself, add 16. Let's add that to both sides. Gives me x squared plus perfect square. Y times itself is y squared. Adds, multiplies is half of the 8, which is 4, equals 108. So the center of my circle has been moved left or right 0, and then down 4. So 0, negative 4 is my center. The radius squared is 108, so r would be the square root of 108, which is, this is a little tricky to reduce this. It's the square root of 36 times the square root of 3, or 6 root 3. And number 10. Group your x stuff first. So let's move our x squared over, so that'd be x squared. Move your 2x over as well, so that'd be x squared minus 2x, leave a space. Plus y squared plus 10y, leave a space. Move your constant to the other side, so equals negative 2. Completing the square, take half of it, multiply it times itself. Don't forget to add it to both sides. Take half of it, add it, or multiply it times itself. Don't forget to add it to both sides. Completed square, now let's factor it. X times itself is x squared, adds, multiplies is half of negative 2. Perfect square, y times itself gives you y squared, adds, multiplies is a positive 5, equals. The other side gives you 24. So therefore, the center of my circle has been shifted right 1, down 5, right 1, down 5. The radius is the square root of 24, which is the square root of 4, times the square root of 6, and you are finished.